This video is going to talk a little bit about concave mirrors. First, we're going to talk a little bit about the difference between concave and convex mirrors. So these are going to be spherical mirrors. So you can imagine that if you have a hollow sphere, and you cut a slice of it, and then sort of silvered either the inside edge, which would create a concave mirror, or the outside edge, which would create a convex mirror, that's potentially how we could get a concave or a convex mirror. So we have this sphere with a center C, and we take a sliver of it and make one side reflective. We're going to specifically focus on concave mirrors. And I want to just define a couple of things for you. So here we have sort of a zoomed in image of a concave mirror, the way we're sort of generally going to see them. And along here we have what is called the principal axis. So the principal axis goes through the center of curvature, C, which we're going to talk about in a bit. And it goes into the geometric center of the mirror. All right, so we generally draw this principal axis. Now C is going to be the center of curvature. Which, if you could imagine, was also the center of the hollow sphere from which this mirror was cut. It is always along the principal axis. We also have F, which is going to be our focal point. Oh. Which is halfway between the center of curvature and the mirror. And then we have this A. A is considered the vertex. It is located at the geometric center of the mirror, where this line that includes C and F, called the principal axis, intersects the mirror. Now, a couple of distances. Here we have noted distance R. This is the radius of curvature. Notice that that would be the distance from the center of curvature to the mirror, and that this would be the radius of the sphere from which this mirror was cut. And then we have lowercase f, which is called the focal length. And that is the distance from the focal point to the vertex. Also note that the focal length is half of R. So those are just some terms for us to think about. When we reflect off of concave mirrors, we obey the law of reflection. And so you can have an incident ray, and it will reflect and create a reflected ray, and the angle of incidence is equal to the angle of reflection. Note that it doesn't necessarily look that way when you just look at the incident and reflected rays, but if you draw the normal, which remember the normal is 90 degrees to the surface, it's perpendicular to the surface at a given point, and it might not look it from here, but if you zoomed in, this normal line would be perpendicular to the surface at the point that the ray was reflected. And what's interesting is that in this sort of reflection, all normal lines will pass through C, the center of curvature, and they will all have the same length R because they are effectively a radius. If you could imagine here, you have a radius here, a radius here. It is effectively a radius of your sphere. So what makes this convenient is that all normals pass through the center of curvature. So how does reflection look for this, right? In order to produce an image, we need to have rays seem to converge. And what's interesting about concave mirrors is that the rays converge in front of the mirror. And so your image is located in front of the mirror where there are actual light rays, and that creates something called a real image. You can go on YouTube and find a bunch of really cool videos about real images and seeing pictures of those, and we'll see one in our lab. And notice also that these images are located in sort of interesting locations. They're not the same distance from the mirror as the object is. And we're going to talk a little bit more about that, but just know that a real image exists in front of the mirror. You could put up a screen, a piece of paper or a screen here, and actually have that image projected onto that screen. You could not do that with a plane mirror that creates a virtual image because the light rays do not actually converge in front of a plane mirror. So that is our intro to concave mirrors.